Hello everybody, and welcome to our next talk. It's about build high secure applications with Eclipse Serializer. My name is Markus Kett. I'm CEO and co-founder of MicroStream, and I'm super happy to be here for the very first time as a speaker and to announce that now Eclipse Serializer is available as a final release. And hopefully today or tomorrow or this week or this month, we will be able to launch also our second new Eclipse project. It's called Eclipse Store. And so we are from MicroStream and we donated the code to the Eclipse Foundation. We started the project at the beginning of this year. And now we are final. That's great. So about myself, my name is Markus, and I work with Java with my team together for almost 20 years. And we started working on a Java development environment. It called XDev. It was a kind of like Visual Basic for Java, and then we migrated everything to Eclipse. It's now called RapidClipse. It's also under EPL, available for free. The framework is open source. It's not an official open source project. Then we worked on the JBoss Hibernate tools, improved the JBoss Hibernate tools for many years to simplify database programming with Java. And then we started the MicroStream project, which is the core is serialization, and the concept is a persistence framework, but the core is, as I mentioned, serialization. We also, of course, a member of the Eclipse Foundation. We're a member of the Micronaut Foundation also. And a question to you. Who of you is an Eclipse contributor? All right. Java developers? Almost everybody. Nice. So the Eclipse Serializer project started almost 10 years ago. So it's bulletproof. It's not only a concept. It's already used and well integrated with Helidon, which is a popular microservice framework. And it's also integrated with Micronaut and many other frameworks. We have integrations with other frameworks, and many other frameworks will use Eclipse Store. So the big question is, why do we need another serialization? Who of you is already familiar with the topic serialization? Okay, nice. So obviously companies don't want to be hacked. So this is the reason why software should be secure. The problem is, in Java we have the Java serialization concept, and the architects of Java say Java serialization was a horrible mistake. So that's a little bit scary, right? So there are other people from the Java architects or the Java community that say it was a horrible mistake. Mark Reinhold said half of all vulnerabilities are linked to Java serialization. Or Brian Goetz said that Java makes almost every single mistake in terms of serialization. And he said in his blog post, there are a lot of other serialization frameworks out there, around 50 or even more, but they all have the same vulnerabilities, or they focus on something else like human-readable formats, but they are also insecure. Which means serialization is everywhere, so almost every framework uses serialization, which means almost every Java application uses serialization, and all of them are insecure. This is not great, actually. So when I heard the talk of Steve Poole from Sonatype the very first time at Java 1, so we were also very scared about, hey, what do we use? Which software do we use? How can we tell our customers, don't worry, because Java, our applications we build in Java are really secure. So what's the problem here? The problem with Java serialization is deserialization. and deserialization attacks. So because of Java serialization, not only transfer data, also class information are transferred. And through deserialization, almost all classes in the class path are executed automatically behind the scenes. And you can't do anything against this. And at this point, malicious code can be injected very easily. So this is not a talk about how you can inject malicious code. So you can find a lot of talks of Steve Poole, for instance. He shows how easy it is to inject, to create malicious code and to inject malicious code into Java applications. There are concepts to avoid to be hacked, of course. So you can do whitelistings, blacklistings, and so on. The problem is, mostly you will be too late. So because of the objects are generated by the JVM, and then, yeah, so we have the problem. So conclusion is mostly, also in the talks about serialization problems, yeah, we have these problems, but we can't do anything against it. So, great. And almost all applications and frameworks use Java serialization. Let's see how this works. So we have our objects in memory, and the serialization framework creates a byte format or a human-readable format, JSON, or anything else. The question here is, why should you use a bytecode serialization? Why should you use a human-readable serialization? So the human-readable serializations like JSONs, they are very fast in comparison to Java serialization. The problem here is if you have complex object structure, so complex object graphs with circular references, then you're in trouble with JSON serialization. This cannot be covered by JSON, for instance. So if you have flat objects, no problem. If you have very complex object structure, you cannot do this with JSON. Then the serialization framework transfers, as I mentioned, data and class informations also. And now through deserialization, we let the JVM, so we let the JVM create the objects with this based on the class informations and based on data we get from the serializer. So the JVM creates the objects, and at this point, blacklisting or whitelisting will come later, after the objects are already generated. So this is the reason why we mostly cannot avoid with black or whitelisting to be hacked. And of course, black and white listing is always limited. The Eclipse Serializer works fundamentally different from this approach. And this was our main goal when we started the MicroStream project almost 10 years ago. Because our requirements were, we wanted to serialize very complex object structure and transfer and store complex object structure. So it was not possible to use JSON or XML, something like that. And other serialization frameworks, as I mentioned already, they are also insecure in terms of deserialization attacks. So with Eclipse Serializer, we also, of course, create a byte format. So this is an individual defined bytecode format. We transfer only the bytecode, and the Eclipse Serializer now writes the class information directly into the memory. So we create the objects, the serializer creates the objects on heap, and the JVM is not involved. So we do not use reflection. This is done by the serializer. At this point, deserialization attacks are not successful because so we do not execute code. We never execute code. This is the main point and the main difference to all other serialization frameworks. We also have limitations with the Java serialization. So for some people this is important, for many people it's not important. For us this was very important because we wanted to make sure that you can serialize almost all Java types. So everything that can be recreated should be serializable. And this is not possible with Java serialization because with Java serialization you have to implement the interface serializable. Objects that do not implement serializable cannot be serialized. Then we have performance issues, of course. So Java serialization is known as slow, and the complexity of an object graph is also limited. So Java serialization is in trouble when you have really huge object graphs, very complex object graphs with circular references. This is a problem with the Java serialization. And there are some methods executed like magic, so you have no control about this. Also, schema migration is challenging with most serialization frameworks. So if your classes change, then this might be a problem. So for us, this was a requirement that schema migration should be covered. Alternative frameworks, so there are a lot of frameworks out there. Check this out. There are around 50 or even more serialization frameworks. The bytecode-based frameworks have mostly the same problem. So they use reflection, they execute code automatically behind the scenes, so they have the same security flaws and make the same conceptual mistakes. So mistakes, this is what Brian Götz said. And most of them are based on the Java serialization. So, same mistakes. The human readable formats, of course, or the serialization frameworks, they are focused on the format. So because of, we want to provide and use JSON. As I mentioned already, so they have problems in terms of the complexity, circular references. This is not possible with human readable formats. There are a lot of overhead. Parsing is, of course, and is required. Performance, so it depends. So most of the later human readable serializations are not that slow. So the JSON serialization is also meanwhile very fast. So we talked already about how the Eclipse Serializer works and why the Eclipse Serializer is more secure. So the very important point is we separate data from code. We never transfer class information. No class information are transferred. And we do not execute code. So this is very important. Objects are generated by the serializer, not by the JVM. So the Eclipse Serializer writes all data directly into the memory on heap. So then you have the JVM have the objects automatically generated by the frameworks. So the biggest security leak of Java is eliminated by the Eclipse Serializer. And using is very simple. There are also no limitations with the Eclipse Serializer because of you don't have to implement serializable. Almost all Java types can be serialized. Almost means everything that can be recreated, so you cannot serialize a thread, of course. So there is actually no interface you have to implement. There are no annotations, so this is very convenient. You can really serialize POJOs, also objects from Third-party frameworks can be serialized very easily, and there are no requirements to your classes. This was very important for us, so no specific requirements, no superclass. This was very important for us. And because we were focused actually on storing objects on disk, for us what was very important when we created the framework that you can really deal with very complex object structure. As I mentioned, sometimes or very often this is not important for developers. Sometimes this is very important. So this is built for high complexity, high complex object structure. Circular references, you can deal with circular references. There are no limits in terms of the depth of your object graph. So you can have almost billion of nodes in your object graph, and it can be serialized. Schema migration is very simple with Eclipse Serializer. So if your classes change, this is not a problem. We provide a concept that is called legacy type mapping, and the serialization framework cares for schema migration. And you can, so the easy cases are done automatically behind the scenes, and for more complex schema changes, you can define a legacy type mapping. Florian, maybe you can show some code how this works later on. There's no magic code to show, so this is very straightforward, very simple to use. You can check out the code now. It's available on GitHub, of course. Performance. So this is our internal performance test. So don't trust our test. This is internal. Check it out for yourself. Eclipse Serializer was very fast. So here we really used complex object structure. We measured also that JSON serialization is very fast and can also be faster with flat object structure. So with simple objects, this might be faster. The more complex your object structure is, the faster the Eclipse Serializer will be. Requirements, there are almost no requirements. The only requirement is Java version 8, right? And we move to Java 11 in the near future. So it runs wherever Java runs, wherever a JVM is. It even runs on Java cards. It runs, of course, in the desktop, in Kubernetes, pods. With GraalVM native images, we tested this. So this is no problem. Runs in containers, so you can use it with microservices. And it runs also on Android. Is anybody developing Android apps? Or apps for edge devices? No one? Boring stuff. So now it's very important for automotive projects and the Eclipse Foundation. We have a lot of automotive projects, so you can use it also with this stuff. So where are the cons? So it works fundamentally different, and we had a discussion, so we had further discussions with Brian Goetz. We talked about, so how can we support the Java ecosystem? How can we donate this to the Java community? How can you guys use it to make Java more secure, make your frameworks more secure? Brian said, so okay, this is great stuff, and Java community should use it. The problem is they cannot use it in the Open JDK. It's because of it has to be compatible. Everything has to be compatible in Java, and you cannot replace serialization because it is used by almost all frameworks already. So you cannot change this. This is the main problem. But you can think about using secure serialization when you build new applications, new frameworks. Of course, then we can use now a more secure solution, and then you can think about using Eclipse Serializer to make your project more secure, and this can be a great benefit for your customers, for your frameworks to provide high secure software. So this is not a drop-in replacement. This is the biggest cons, I would say, with Eclipse Serializer. Migration is easy. This is not really a problem. It depends on how many dependencies you use. So because most of frameworks use serialization, you use mostly a lot of dependencies, you cannot migrate all or rework all of your dependencies. So check this out and yeah, think about, is this a benefit for you or not? And there is only implementation for Java. Maybe this is also another cons here. So serialization frameworks like protocol buffers are built for transferring data through multiple programming languages. So this is easy and it's great stuff. With Eclipse Serializer, we have an implementation for the JVM, which means you can use it with all JVM languages. You can use it in Java. You cannot use it in C# or other programming language. So far, it is an open source project. It's an Eclipse project, so everybody's invited to join us and to build a C# implementation. For instance, who of you is a C# developer? No one? Okay. Python? Everybody's Java developer. Yeah, great. Yeah. So the roadmap. So microstream development does now end. So we donated everything to the Eclipse Foundation, and now, so migrating, of course, is easy, and the following versions, so will be Eclipse Serializer version 2, 3, and so on. And we have, of course, a roadmap, and so we plan to release every single year a major release, but of course, if there are security issues, something like that, then we will provide updates instantly. So check this out. The code is on GitHub. Florian, do you want to show some code, for instance?
Yeah, sure.
We have some minutes left. And then we will have some time for Q&A. If you have some questions, please feel free to ask your questions, so you can interrupt us anytime. Yes, please.
What happens if you serialize with JDK, for instance, 21, and you deserialize with another JDK version? Is it compliant with the version? JDK 17 or JDK 11, for instance? What are the versions?
You mean if you changed your JVM version?
It doesn't matter. So the only if the class is actually changed. So if in a JDK a field got added and so on, you have to do the legacy type mapping. But if the classes don't change, the JDK version doesn't matter at all. Yeah. All right. So the best starting point, of course, is the code at GitHub. We just released the first official final release last week. It's available at Maven Central, and like every serializer out there, it's really easy to use. So just instantiate the serializer and call the serialize and deserialize method, and that's it, basically. So the most used version, of course, it will be the byte array-based. We have a byte buffer-based one, and we are currently developing a stream-based one, so you can directly stream your bytes or use output and input streams or channels. But you can do this, of course, with the byte arrays as well, or the byte buffers, and just wrap a stream around it. Yeah. So this is the most simple use case. You can do a lot of customization. The whole framework is interface-based, the design of it. So everything can be re-implemented and configured. So if you have special needs, just exchange all the stuff. You can define which fields should be left out by the serializer. The default implementation uses the transient keyword like the Java serialization, but you can exchange that as well. You can configure down to the last byte how every object is serialized actually, or the conversion between object and the binary format should be done, but we call it type handlers. In the Java serialization, you have to implement the conversion inside your Pojo. So you can only control the byte format conversion if you own the code. You cannot configure the conversion for external libraries or the JDK types. So we decided to use an external configuration. We use type handlers which can be registered in a serializer, and then you can configure any type which you want to serialize. So if you like, you can say the Java util array list should be serialized in this and that way, if you want to. Of course, for the most common use types, Java collections, datetime, and so on, we provide highly optimized type handlers, which use a very efficient format, but you can customize that as well if you like. And how this can be done can be found in the documentation, of course. We don't have time for that to go into the detail, but every customization is described in the documentation, how you can define custom type handlers, how the legacy type mapping is done. So if you change your code base, which will happen over a lifetime of your application, of course, there's always a version 2 and 3 and so on, so you can migrate an unlimited amount of versions. So you define how version 1 to 2 is migrated, 2 to 3 and so on. That's no problem at all. Like Markus said, the most common cases, like adding new fields, renaming fields, can be detected by the engine. But if you have a more complex stuff, like you split field name into first and last name, for example, you can define the legacy type mapping by yourself and do the byte conversion by your own. Yeah.
Could you switch back to your other example? Could you elaborate a bit on the concrete technical difference from the standard serialization? You said you do not transfer the class information, just the data. So how does the deserialized data line knows that the data is an accompanying object?
Depends. Sorry. If you run the code in the same JVM, you don't have to define anything.
But it's not the normal case.
Depends on the use case, of course. So, but if you send the code to a different JVM, you have to define a whitelisting as well to say the serializer this and that types should be used, or you transfer or share a common type dictionary. It's an external file where all the use types are listed, and you can put this list, for example, in your code base and share it between the JVMs. That's one way to do it. But we had to use some sort of listing or external type information handling in order to ensure a correct deserialization and to make it secure, of course. If you transfer the class information as well as the JDK does, we wouldn't have solved the security issue. So, yeah.
And so you only have to list the top level class names and not
All of them.
class graph?
All of them.
All of them?
Yeah. But it can be done automatically. You can run the serializer once over your object graph in a dev environment, and the file is generated, and you can use it at runtime. Yeah. Yeah.
I think different projects are now using also content programming language, because what benefit from using content is that you can change the target that you can build your application also for the JVM for example. So I'm interested in if you
Kotlin works. There are examples out there. I just found an article where someone used it for Kotlin with a Spring monolith. There are some types which require attention. I think it's the immutable collection types. We need special type handlers for that. But the mutable collection types work, and Kotlin works fine. Yeah. Yeah.
I want to zoom in on the question about the line deserialized data. Is it important that it's the same serializer instance that you deserialize?
No.
So the data array contains, I would assume, an integer that points to the class of the object that you're deserializing. Otherwise, you wouldn't know what you.
Yeah. The format is open as well, of course. So one record of the serialization stream consists of first a type ID, which is used as a reference, then object ID, which is a unique ID we generate internally, because we have to know which object references what object and to restore the referential integrity, and the other fields of the records are the data, the raw data, like the memory manages the data on heap. The JVM memory layout is basically copied into the stream format. Yeah. Yeah.
This is a stupid question, but why do you not need to cache the output of the serializer?
Output. I think it's a generic magic. Yeah. Yeah. So it doesn't return object, it returns T, and yeah. Yeah, but the deserialize method uses a generic return type. Yeah, not object. Yeah. Okay. All right. So the project is still in its on the Eclipse Foundation. It's still in its early stages. We will open the GitHub discussions, I guess, next week. So you're welcome to get in, bring ideas, and we are gladly open for new stuff, new ideas which come in. All right.
There is another talk today in the afternoon about how we store objects. And the Eclipse Serializer initially was built for the purpose of storing data. So we were actually, at the beginning, not really focused on security. It was important, of course, but our vision when we started the project was storing objects. And storing objects without the need of dealing with databases. So this might be a little bit crazy, but as I mentioned, we started with a Java development environment with a kind of like Java for Visual Basic. It's called Eclipse, and we built this beautiful GUI builder where you can design user interfaces in minutes. It was great, and our users were super excited, and we were successful. The problem was, as soon as they want to show data on the screen, they were in trouble. Why? It's because of database development in Java is so complicated. So then we teach them, hey, you can use Hibernate. So with Hibernate, we in Java store data with objects with Hibernate. Super simple. Yeah, of course. Then everything was really slow, and users were disappointed about the performance. Then we said, no, it's not a problem, you can add a cache. Okay, then added a cache, then had problems with cache configuration, and some of them wanted to build distributed applications and had problems with data consistency. Then we said to them, yeah, it's not a problem, we can solve this. You can use a distributed cache, put the cache in between your app and your database. Okay, another layer. So it was not visual development anymore. So, and we were not able to solve this. We worked on JBoss Hibernate tools. We invented JPA SQL, so kind of like query language to simplify type safe queries in Java. it was not successful. So we thought about something completely new. So the vision was crazy. The vision was Java should care for persistence. So because we are Java developers, we don't want to deal with external database system working fundamentally different from Java. So why not creating a system that cares for storage like magic? So just focus on your code, and the JVM cares for everything. And our idea also was actually, why should we have to solve this? Why not the hardware vendors? So actually they should care for persistence. Come on, man, you're crazy. This will not work. Then Intel invented persistent memory. So the idea was that the hardware cares for persistence. But so it doesn't work like magic, and persistent memory is not that popular. So Intel sold the persistent memory stuff to another vendor. Nobody talks about persistent memory anymore. So why not building a software that cares for persistence? And the Eclipse Serializer is the core of that. So now we have a framework, and this is not our invention. So gaming companies and banking companies, they follow this functional principle already. They use it already in production for many years for building their high-frequency trading applications. So they need best possible performance, and databases are too slow. So they build everything in Java, but the problem here was, so they are successful, they're doing this, but they have to build an in-memory database system for their own, for every single application. This is too effortful and too expensive for common applications. But now we have a framework for that. So with Eclipse Store Serializer is the core of that. We are now able just to kind of like mirroring the memory with a storage, like plain file storage or an object store like AWS S3. So with this concept, you can mirror your objects with an object store, no more classic selects, fully object-oriented, and high performance. In this talk, you will learn about how this works. Allianz, Fraport, and other companies use it already in production. Join us in the afternoon, and then we will introduce this concept. If you have further questions, we have a booth out there, so you can ask questions. Thank you for joining. Have a great day at EclipseCon. Thanks.